Good morning, this is Kasturi Day. Today I have come to discuss the question answer series of the matter chapter according to ICSE syllabus class 8. Okay, so I'm starting with the question answers of today's video. First one is describe the process of condensation and sublimation with examples. See, the process of condensation is the change of the vapor state, the change from the vapor state, change of matter rather, you can say, from its vapor state to its liquid state at any constant temperature, at a constant temperature. Okay, on releasing heat. Okay, this change of state from the vapor state to the liquid state happens at a constant temperature, and during this at this constant temperature there is a release of heat, or on cooling you can say, that is known as condensation. And during this process there is no further decrease in the temperature, no change in temperature takes place, only the change of state takes place and the temperature remains constant at that point. Okay, so this fixed point of temperature, when there is a change, when this change takes place, when the change of the state takes place, that is known as condensation point. Okay, for example, steam, that is a gas or vapor, at 100 degrees centigrade condenses to water or liquid, water which is a liquid, at 100 degrees centigrade on cooling. So the temperature remains at 100 degrees centigrade and the steam, that is a gas, changes to water, that's a liquid. Okay, by rejecting heat, by releasing heat. Okay, now second was sublimation. First was condensation that I discussed now, and the next one is the sublimation. Sublimation is a process by which a solid changes directly into vapor when heated. When the solid is heated, it changes directly into vapor, that is its gaseous state, without changing into liquid, without transforming into liquid, without melting into liquid. It directly changes into vapor. In some solids where the intermolecular force of attraction is very weak, okay, solids, we know that intermolecular force of attraction is very strong. Okay, but in some solids this intermolecular force of attraction, that is weak. Okay, and those solids, they, what happens, they, when heated, they acquire sufficient kinetic energy to overcome this force of attraction, and they become free to move, and thus changes into gas, that directly into vapor, not into water and then into vapor. I mean, not into liquid and then into vapor, but it directly changes to vapor. When for example, when ammonium chloride is heated, it directly changes into its vapor. Again, on cooling, it directly changes into ammonium chloride solid without becoming liquid. Now state three factors which affect the rate of evaporation of a liquid. First is the temperature, second is the area of the exposed surface, third is the nature of the liquid. Here we have to ask for three factors. Okay, so I have told you three: temperature, area of the exposed surface, and the nature of the liquid. So first we need to discuss, describe these three. So first one is temperature of the liquid. The rate of the evaporation is higher when the temperature of the liquid is higher. That is, when the liquid is heated, the rate of evaporation also increases. Okay, that is, it evaporates much faster. For example, when a wet cloth, okay, that has water content in it, when it is dried in hot sun, so that liquid, that is the water of the cloth, that becomes the temperature of that water rises. Okay, that liquid becomes hot, and so in the hot dry summer, or in the hot day, what happens, it that hot liquid, that hot water, that evaporates much faster than the wet cloth, which dries up on a cold day. Okay, second is the area of the exposed surface. When the exposed surface, when the surface which is being exposed, rather, when we place a liquid in a more broader surface, where the area of the surface area is more, than a narrow and than a small surface, that there the evaporation is much faster. So what happens when we place a tea in a cup and we place tea in a saucer, so the liquid or the tea in the saucer evaporates much faster than the tea which is in the this cup. Okay, so the rate of evaporation increases if the area of the exposed surface increases. For example, a cloth dries up faster if it is spread out. Okay, if it is spread out than if it is folded. When you fold it and keep it, that takes a longer time to dry up than if you spread the cloth totally, that will dry up much faster. Third point is the nature of the liquid. Volatile liquids which have low boiling point like alcohol, spirit, ether, they evaporate much faster than water. These are water has high boiling point. So the liquids which are volatile, which has low boiling point, that evaporate much faster. So evaporation also depends on the nature of the liquid. That's why these liquids, that is alcohol, spirit, ether, these are kept in tight closed bottles. Next we come to some reasoning. Wet clothes dry more quickly on a warm day than on a cold humid day. Explain. Because as I told you this previous question only, that because the rate of evaporation is higher if the temperature of the liquid is high. Okay, therefore the water, that is the liquid on the wet clothes, become warm due to the warm atmosphere and so evaporate faster. Then water in a dish evaporates faster than in a bottle. Give reason. Because the rate of evaporation increases if the area of the surface exposed increases. Okay, so therefore the dish has more exposed surface than a bottle, so water in a dish evaporates much faster than in a bottle. Then why do our volatile liquids such as alcohol and spirit stored in tight closed bottles? Because volatile liquids have low boiling point and evaporate much faster than water. So these liquids acquire heat from the surroundings which raise their temperature to their boiling point and they convert into their gases. So they are stored in tightly closed bottles so that even if the temperature, even if there is a change in the temperature, the rise in the temperature, they will not be able to escape from the bottle. Okay. Why is cooling produced on evaporation of a liquid? Because for cooling in evaporation, that is when liquid changes into vapor, it requires heat. This heat is supplied by the surroundings of the liquid. This results in fall in the temperature, that is cooling occurs in the surroundings. Okay, so what happens? When the liquid changes into vapor, it requires heat. Okay, so the liquid will gain the heat, and what happen, it will gain the kinetic energy. The molecules will gain the kinetic energy and then move faster to become vapor. Okay, to become its gas. So this heat is taken from the surroundings, and so as it is absorbing the heat from the surroundings, it is cooling the surroundings. That's why there is cooling effect during evaporation of the surroundings. Explain with an example that when a liquid evaporates, it takes heat from its surroundings. For this, let us take some alcohol or spirit in some cotton or wool. Then that cotton or wool is wrapped around a bulb of the thermometer. We see that the thermometer reading falls. This shows that cooling is produced when a liquid evaporates. Okay, the reason for the cooling in evaporation is that when the liquid changes into vapor, it requires heat, and which is supplied by the surroundings of the liquid. Here, the cotton wrapped around the thermometer, it is taking the heat from the cotton. So therefore, it is taken from the cotton. Okay, and therefore it will result in the cooling effect of the cotton, and therefore the thermometer will show cooling effect, that is the temperature will fall. Okay, give two applications of evaporation. In summer, water gets cooled in an earthen pot. And another one is doctors advise to put the strips of wet cloth on the forehead of a patient who has high fever. Okay, then explain why in hot summer days water remains cool in earthen pots. It's because water seeps out. The earthen pots have pores on them, and the water seeps out of on the surface through these pores. Okay, and when they come out through these pores of the pot, they take up the heat from the surroundings. Okay, and they evaporate after absorbing this heat. Okay, from the water, the water which is coming out through the pores, they will absorb the heat from the inside the water which is inside the pot, and they will evaporate, thus making the pot water cool. Then a patient suffering from high fever is advised to put wet cloth strips on his forehead. Why? Because water on the strips, they evaporate by absorbing the heat of the body from the patient. Okay, from the body of the patient, and thus bringing down the temperature of the body. Next we come to, why does the size of the naphthalene bottle decreases when left open? Because naphthalene balls have molecules which have weak intermolecular force of attraction, and these molecules, when kept in open, they absorb the heat from the surroundings, and the molecules of these balls acquire sufficient kinetic energy to overcome this force of attraction, and they become free to move and become vapor and evaporate directly into vapor and evaporate. Okay, next we come to describe an experiment to demonstrate the process of sublimation. So see, this is the process of sublimation as a picture rather. We have placed a wire gauge over a tripod stand, and the tripod stand, underneath the tripod stand there is a Bunsen burner, and over the tripod stand there is a china dish which has some aluminium chloride in it, and it is covered by a funnel. Okay, inverted funnel, and is the neck of the inverted funnel, the mouth of the inverted funnel has been closed by a cotton piece. Okay, now this this ammonium chloride which is inside this china dish, that when it is heated by a burner, it evaporates directly into vapor, and it sublimes. Okay, so for this we need to take some ammonium chloride, then let us make it a powder. Then powdered should be kept in a china dish. When it is then covered with an inverted funnel, the end of the funnel is closed with a piece of cotton. Then we need to place the dish on a wire mesh which is kept on a tripod stand to heat it by a burner. We will notice that the burner fumes of aluminum chloride is coming out in the funnel above the dish. These vapor upon rising get cooled and change into again solid ammonium chloride, which get collected in the neck of the funnel deposited there. Therefore, the ammonium chloride on heating changes directly from solid to vapor, and these vapor on cooling directly changes into solid ammonium chloride. So this experiment is a demonstration for the sublimation. Okay, so I have ended this chapter, this question answer series also. So please go through this. If you have any doubt regarding this chapter, these questions, or any other questions regarding this chapter you want to know, or any other chapter you want to discuss, okay, so please let me know. Please do write in the comment box. Okay, and if you like the video, hope you are liking my videos, so please do respond. Please press the like button. Please share with your friends, and if you are a new viewer to my channel or not subscribed yet, please do subscribe to get the notification of my next video. Thank you.